This is a video for you if you were not here in class for this activity we did with the board. It's really helpful to visualize what's really happening within an electroplating lab before we do the lab. So what our materials are for the lab: we have a battery that you've definitely seen before. We have the battery connected to two electrodes, these rods that are going to be made of graphite. We have positive and minus signs for our illustration. We have electrons that are in a direction, and we have two types of ions. We have a positive ion and a negative ion. What is the name of the positive ion? This is a copper 2+ ion, right? Because it's the metal, so the metal is going to come first. What about the name of this one? Check your polyatomic ions list. This is a sulfate ion. So sulfate has a 2- charge. Together, they form what type of bond? These two are going to come together to make a neutral ionic compound. So they have an ionic bond, right? But when they're in solution, ionic compounds, when they're in solution, can dissolve. Like salt dissolves in water. You put salt to make in pasta water to flavor pasta when it's cooking. So you know that salts dissolve in water. So when we put our copper sulfate in a solution, it's going to turn blue. It's going to be very pretty. We have a solution of copper sulfate ions. Just sprinkle them around here, and they're all floating randomly in this solution. When we add a battery, this battery, we started off with it facing positive end going to the left and negative end going to the right. There's a barrier between your battery that makes it able to stay alive for a while. You can use them for probably 5 years if they haven't been used before, because there's a barrier between the positive side and the negative side. Only when you connect these two ends does it power anything. It cycles electrons. It pushes them out the negative side and attracts them with the positive side. So when we have the battery here, which way should these electrons be facing? If I have an electron on my right-hand side, should it be facing left or should it be facing right? Should it be going out of the negative side or into the negative side? Our electron should be leaving the negative side because an electron is negatively charged. So I leave the negative side, travel down into my electrode. If I add electrons to this electrode, what is the charge? Is it going to be positive or negative? Our electrode on this side is going to match the side of the battery it's on, so it's going to be negative. In your lab, it's going to have a black wire. So our electrons keep going. They go through the solution because we know electrons can travel through an ionic solution. And they're pulled up through here out of this electrode, and they go into the positive side of the battery. If this electrode is positive, electrons are being removed from this electrode, which makes this what charge? What charge is the left-hand electrode? We have a positive electrode. So we have a positive electrode and a negative electrode. We also have positive and negative ions floating in this solution. So when we apply this current that's going through here, we're going to attract one type of ion to one side and the other to the other side. As we know, opposites attract, so they like to cancel out. Which side will the copper 2+ go to? Will it go to the positive side or the negative side? The copper 2+ will go to the negative electrode because it is a positive ion. So all of our little copper 2+ ions will go to the negative electrode, which means all of our sulfate ions will travel toward the positive electrode. When our copper 2+ ions are over here, they're being met with a constant stream of electrons. What do you think will happen when a copper 2 plus ion, so it has a 2 plus charge, is met with 2 extra negative charges from 2 electrons? What will happen? These 2 electrons will cancel out the positive charge on the copper, making it copper solid copper. Is solid copper soluble in water? Yes or no? No, metal is not soluble in water. Metal ions are soluble in water. So now that it's just the metal, it will start coating this electrode over here that was once a gray color will now start turning copper, shiny copper, because all of these free electrons are interacting with these copper ions. What will happen when we swap the battery's orientation? Now all of our electrons are switching to move this way, and our electrodes now swap charges. What will happen to our ions? Our ions will swap sides. So our positive charges will want to move toward the negative side, and our negative charges will want to move toward the positive electrode. So the once copper-coated electrode will lose its copper coating, move toward the other electrode, and coat this electrode with copper. If you understand what's going on here physically, it'll make the lab much more clear, and you'll see in person how this can be applied.